Hello, everybody. Welcome to today's math class. Today we have a very nice exponential equation before us here. Now, how do we solve this algebra? It is very easy. If you look at this, you can tell the answer, but you may only be able to tell one of the answers. Look at the highest variable here is 3. So this number here tells us the number of solutions we have to solve for in this question. So automatically we have to solve for 3 roots that will satisfy this equation, both the imaginary and the real root. But if you look at this question carefully, you can tell that the real root is 2. But how about the imaginary root? How do we solve for the imaginary root? That is the essence of this video. So if you're new here, this is Math Pros. If you've not subscribed, do well. Do yourself that good by subscribing. Okay? Then when you subscribe, turn on the notification bell button so that you get notified whenever we release an amazing video. So without much further ado, let's take a solution. The solution. All right. So the question is just x to the power of 3. This is equal to 8. Now I can rewrite it in base 2. In other words, we can have this as x to the power of 3 equal to 2 to the power of what? 3. As easy as ABC. So move this to the side of the equation. So this gives us x to the power of 3, then minus 2 to the power of 3. Yet the right hand side remains 0. Looking at the left hand side of this equation, there is a special algebraic identity that comes to mind, and that is what we call difference of 2 cubes. So now what does it say? It says that if you have your a to the power of 3 there minus your b to the power of 3, this will give us your bracket open, your a minus b close bracket bracket, your a to the power of 2 plus your a b then plus your b square, right? The close bracket. You remember this? Ah, do you remember this? Okay, so we can apply that here. So if we apply that to this, then we can rewrite this, or this now implies that we're going to have this to be x, then minus 2, close bracket, the bracket, our x squared, then plus 2x, then plus our 4. Everything will be equal to 0. Now, we can equate this to this, equate this to this. Apply what we call the zero product rule. We say that if you have your A times B equal to 0, this now implies that we're going to have A is equal to 0 or B equal to 0. Oh, do you still remember this also? Okay, so if you remember this, we're going to apply that here right now. So let's equate this to 0. So we have here x minus 2 is equal to 0. This is our case 1. So let's just solve this first. So this will now give us x will now be equal to 2. So this is the first root, and we call this our x1. That is the first one I said. And mainly looking at this equation, you can tell that the real root here is just 2. But how do we solve for the other root? Are they going to be imaginary root or real root? So we'll take case 2. So from our case 2, we have our x to the power of 2 plus 2x plus 4 equal to 0. So this is a quadratic equation whereby we're going to apply the quadratic formula. We're going to have our x, this is equal to minus b plus minus the square root of b squared minus 4 times ac, right? All over 2a. Look at it very well. Okay, so what is our a? Our a is the coefficient of x squared, which is 1, and the coefficient of x is 2. So we have here, sorry, b. b is equals to coefficient of s, which is 2, and c is equal to the constant term, which is 4. From here, we're going to have here x is equal to the minus 2 plus minus the square root of your 2 to the power of 2 minus 4 times our a is 1 times 4, which is our c, right? Everything all over 2 times 1. Good, good. So we have here x is equals to minus 2 plus minus the square root of 4 minus 16. Everything all over 2, right? So this now gives us x is equals to minus 2 plus the square root of minus 12 all over 2. Good. Now, minus 12 can be expressed or written as our minus 1 times 4 times 3, right? So let's just simplify that. So we're going to have x is equal to minus 2 plus minus the square root of our minus 1 times 4 times 3. This is all over 2. So remember that the square root of minus 1 is equals to iota. You remember this also? Okay, this is a very special identity. Okay, so where I is imaginary, right? So we can represent our minus 1 here, okay, our minus 1 here with this. So let's continue. This will give us here x will now be equal to minus 2 plus minus the square root of 4 times 3, or into our iota all over 2. Okay, now 4, the square root of 4 is 2. So that will give us, so if we factorize 2 out here, we're going to end up having our 1 all over 2 bracket minus 2 plus minus 2 there into the square root of 3 iota close bracket. Then this can cancel out this. So if we use this to cancel out this, then this will now give us here your minus 1 plus minus the square root of 3 iota. So we have our x 1 from here is equal to minus 1 plus the square root of 3 iota, and our x2 is equal to minus 1 minus the square root of 3 iota, right? Okay, so we have our x1, x2. All right, but remember we have solved for our x1 already from here. Look at our x1 here. Oh, we have our x1 here. So we have 3 roots to this expression. So what are the 3 roots here now? So we can now say, therefore, our x1 is equal to 2. Our x2 is equal to minus 1 plus the square root of 3 iota, and x3 is equal to minus 1 minus the square root of 3 iota. Okay, so these are the 3 roots I told you initially that we're going to solve for here. Okay, so when these 3 roots are plugged into the original equation, which is this, our original equation here, they all satisfy the original equation. So this marks the end to this challenge. If you learned something from this video tutorial, give the video a thumbs up, and if you have a better way of solving this, conserving time, then drop it in the comment section. Remember, this is Math Prowess, and we all here loves you. Bye.